Hello guys, how is it going? In this video we are going to take a look at how does a binary tree algorithm works. How does it know where to store the numbers, how to search through the numbers, and etc. So let's get started. How to search through the number. So first of all we will just make a list of numbers. I will choose some random numbers like 6, 5, 9, 3, 4, and let's say 2. So these are my numbers that I will try to store in a binary tree using the algorithm. I will take these numbers to this. So a binary tree starts with a master node. It will hold the first value of the list, so it will be 6. I will store the same list over here. So the first element is the 6. I will store 6 in here, and then I will go to the second number, which is 5. And the rule of the binary tree algorithm is larger number go to the right and smaller numbers go to the left of the tree. So it is relative to the parent node which is above it. So the second number is 5, as you can see, 5. And then I will second number is 5, so I will put 5 in the binary tree. Because 5 is less than 6, the parent node, I will store it to the smaller side, which is the left. Yes, so to the left I will store 5. I will store 5, and then the second and third number after the 5 is 9. So 9 is greater than 6, so it will go to the right of 6, because there is nothing at the right of 6. That's why I can put 9 over there. So I will put 9, and then the second number is 3. Next comes the digit 3. So 3 is less than 6, so we will go to the left. But there is a problem, we already have a digit in here. We can't overwrite it because we want to search through it in the future. So we will make sure, we will check if 3 is less than or greater than 5. As you can see, 3 is less than 5, so it will go to the right of 5. And I am adding 3 because 5 had nothing in the right or left of it earlier. So next comes the digit 4. 4 is less than 6, so we will go to the left, but it is also less than 5, so again we will go to the left, but there is no empty space. So we will check if 4 is less than 3, which it is not, but it is greater than 3, so we will go to the right and store 4. And then comes the digit 2. So we will go through the tree and check if the master node is full. It is, as it is. Then 2 is less than 6, so we will go to the left. 2 is also less than 5, we will go to the left. There is no empty space. but 2 is also less than 3, so we'll go to the right and store 2. And store 2. So as you can see, we have completed our tree, and this is how a binary tree should look like, if you can visualize it in the code. So I don't know if you can see, but this construction of the tree has sorted these numbers in ascending order. If I go to the leftmost node, 6, then 5, then 3, then 2, because 3 has a node to the left assigned a value of 2, I can write in text like 2, and then I will go to the through the tree to the left, 5 to the left, 3, because yes, because 3 is greater than 2 but less than 4. We also want to go to the left only, because we don't want to go to the 2 again, we are already fulfilled it. So we'll add 3, and again now we will go to the left, but now our left part is also fulfilled and 3 is also fulfilled. So we'll go to the right and check if 4 is written. As it is not, we will add 4, and then we will go through the 3 and 6 and 5, because this portion is completed. We will add 5, and then we will go to the 6, because we have completed the leftmost portion. We will also add 6, and then because the leftmost portion is completed, we will go to the right of the tree and we will get the digit 9, and we will add the digit 9 to the list. So now there is no digit left in the tree to the left or the right of the 9. So this is our array after the insertion in the binary tree. As you can see, this array is sorted, this array is not sorted, and this is sorted. A binary tree also sorts the array as much as it stores. So this is how a binary tree works. And with that being said, I will end this video here. Make sure to like, share and subscribe, and drop your valuable feedback in the comment section below. Goodbye.